Good afternoon and welcome. I work with BNP Paribas, which is a French investment bank, delivering numerical analytics and tools for traders on the trading desk. We use C++ for the core analytics and Python for scripting and customizing the analytics. And we also work with the GUI team who develop WPF and JavaScript front ends. So I'm going to talk about Clojuresspec. Clojuresspec is a framework for writing schemas for an application's data and function arguments. I think it's a significant development because it addresses one of the key concerns that people have when they're moving from statically typed languages like C or C++ to dynamic languages like Python and Clojure. But unfortunately, I don't think it's as well known as it might be. Data conformance is not as sexy a topic as some others related to UI development, so this hasn't had as much coverage as it might have done. That's a real shame, because I think this can have a huge positive impact. And even better, it allows for a more complete specification of the data schema than is possible in languages like C and C++. So my aim with this talk is to give you a glimpse of what it can do and to motivate you so that you'll be keen afterwards to go and find out more about it. So, as I said, we use C++ for the core numerical analytics. It's a powerful and a fast language, but it can also be cumbersome. We require a bank of regression tests to ensure quality. We can release the library once every couple of months, and only developers who have a strong background in computer architecture can contribute to it. In contrast, dynamic languages like Python and like Clojure are much more agile, expressive, and also they're more intuitive for developers who are more data scientists than computer architects. But with that freedom and that agility comes the worry that we often have that the data may not always be in the format that we're expecting. Clojuresspec allows us to trap those problems much more quickly. So the trouble we often have is we end up writing large numbers of regression tests to convince ourselves that we're always handling all the possible formats of the data that we might have. And that's expensive, and it hurts agility if every time we want to make a change, we have to maintain our tests in line. Or our other option is just to accept that we're going to have failures and make sure that we can jump in when that happens and fix problems quickly. Another thing that we're looking at in the bank is allowing data scientists to develop tactical UIs for their tools, used in an agile fashion using Clojurescript, rather than relying on a GUI team to do that for them. And I'm anticipating that Clojuresspec will be a great help with that initiative. Now, if we have a data conformance problem, we always find out about it sooner or later, but it's much more painful to find out about it later. What typically happens is that the application starts to behave erratically, and we have to break off from what we're doing and track back step by step through all of the transformations of the data, looking for the source of the problem. Bruce Howman gave a famous talk introducing Figwheel. In that talk, he discussed the importance of flow. What he calls flow is a state of mind in which you're trying new code, testing and improving it in a smooth mental process. These mindless interruptions looking for the source of problems break your flow and hinder your creativity. Clojuresspec allows you to write a schema that will alert you as soon as you come across non-conforming data and showing you exactly where the problem occurred. In other words, it helps you to stay in a state of flow. So let's look at some examples. I'm sorry, it's a little bit faded on the screen. So these are all real problems that I came across when developing a demo SVG editor applications. I'll give a link to the source code at the end of the presentation. We used unique IDs to identify SVG objects on the canvas. And these IDs are encoded as strings so that we can store them in the DOM. But it's much more convenient for the application to deal with vectors of integers. Unfortunately, it's very easy for the programmer to forget the conversion from string to vector when reading an ID, and that's exactly what's happened here. We've forgotten this call to string to ID, which I've commented out on the slide. We use a precondition for any function that takes an ID as an argument to assert that it's either nil or a valid ID. And in that case, that gives us the assertion that you can see here, telling us that the string is invalid because it's neither nil nor does it conform to the specification for an ID path, because it's not a collection, and if it's not a collection, it cannot be a vector of integers. In this second example, a mouse event handler is expecting to receive a coordinate pair as a vector of numbers. But in fact, it's receiving a pair of nils. This is because the library that we're using is not compatible with the property renaming which the compiler performs as a part of advanced optimization. Without Clojurescript, we'd find out about this problem when the paths stopped rendering correctly, and we investigated and discovered that our SVG is full of nans, as you can see here. Instead, Clojurescript will give us an assertion immediately telling us that the event handler was passed a pair of nils, and we can jump in and fix the problem straight away without all of the investigation that we would have had to otherwise have done. I mentioned in the introduction that we can write specifications which are more powerful than what can be achieved in languages like C or C++. For example, in C or C++, it's easy to insist that a probability is a floating point number, whereas with Clojurescript we can also insist that it lies within the range 0 to 1. We can do that with a simple specification like this one, which will give us an assertion like that for an out-of-bounds value, and tell us which of the predicates failed, in this case the condition that it must be greater than or equal to 0. We saw before that we're encoding object IDs as strings to be stored in the DOM. We've done that simply by separating the integers with slashes. I can not only insist that that's a string, but also that it conforms to a regular expression which I provide. And that will give me an assertion if ever I try and pass an ID 2/nil/3, alerting me to the fact that it doesn't match my range X and is therefore not a valid ID. We can even handle specifications that would require a type hierarchy in C++. For example, we can write a specification for a vertex. There are many different types of vertex. I've shown two on the slide, one for a vertex with Bezier handles and one without, along with their specifications. A vertex requires different properties depending on what sort of vertex it is. So we can handle that case by using a multi-method to dispatch to the specification for the appropriate type of vertex. As you can see here, we're dispatching to the no handles or the symmetric vertex spec, depending on the vertex type. And having done so, I can check conformance by simply asserting that any value is of type vertex. I can't do justice to Clojurescript in the short time available, but I hope that I've shown you how it can help you to stay in a state of flow and motivated you to go and find out a bit more about it. I'd like to express my gratitude to everyone who's worked on Clojure, Clojurescript, and Clojurescript, and to the organisers of the conference who've given me the opportunity to tell you about it. I'll leave you with some links to the documentation, a demo app, and to Bruce Howman's excellent talk on Figwheel and Flow. Thank you.